Today we will discuss about linked list and what's the use of it. And on this video we will implement single linked list in TypeScript. Hi everyone, this is Subrat and you are watching Fun of Heuristics. So on this channel you will get to know about the programming languages, the framework and all about the algorithms. So please consider subscribing and hit that bell icon if you haven't yet. So first of all, what is a linked list? So in computer science terminology, linked list is a sequential list of nodes which is connected to each other and that can hold some data. But if you want to compare it to a real life example, think like it's a train but you have only two doors to enter. That is, one door is the first cabin and the last door is the last cabin. Only two doors to enter to the train and you can go in between them. So that's what a double linked list is. And a single linked list is, think like you have only one door, you can go to the last. So that's the basic of a linked list is. Linked list is a sequence of nodes. So you can see this one is a particular node and it's a sequence of different node, which is, suppose the first node is connected to the second and the second one is connected to the third and third one is connected to the fourth one, and it can contain some data. And this is a single linked list example. If you go for double linked list, then the connection will be from both the side. Okay. Before going into the code or before going into the details of what the data structure is, we'll see what is the use of it first of all, and why you should consider learning linked list. Okay. So first of all, you can compare the linked list with the array. So in the previous video, we discussed about what is static and dynamic array. If you haven't saw that video yet, you can go and check. I will link that video there. You can go and check that one. So there are a lot of things can be done in array which can be done in linked list, but the time complexity or the efficiency will be going to be different. So in some cases, array is good. In some cases, linked list are good. So you will be more clear when you proceed with the video. So in the starting, I'm saying in linked list, insertion and deletion is pretty good. Good means it has a very good time complexity compared to array. You already know that what's happened in dynamic array case. Like if you're trying to insert more data, it's trying to double its size and trying to insert all the data. In static array, static, you can do it. So you have to copy all the data again to a bigger array. That's all thing. That's not going to happen in linked list. The linked list is used to implement stack queue data structure. So in this video series, we are going to implement queue using linked list. So that is going to come in the future videos. One more use can be in the hash table. That also we're going to cover in the future video. In the hash table, so when the collision happen, the data will store in a linked list, so that accessing the data will be going to be easier. Best example, a use of a double linked list is in the browser. When you press back, forward, that's all maintained with a double linked list. I will show you some terminology. So what a linked list use. Suppose this is a train and this is the first cabin. So this you can consider it as a head. And this will be assigned to null. So we can say grounded, that means it's null. And this value is your tail. In some implementation, you will see in a single linked list, you have only head, you don't have the tail, because it's not that required, but it's better to have, and you will have a pointer. So now we're going to see a graphical implementation of linked list. So in a single linked list, you can tell there are two blocks are there. So it will be more clear when you're going to see the code. But for now, just think like in a node, there are two blocks. One block is meant for data. So wherever I'm writing D is for the data, and the second block is to store the pointer or to store the address of the next node. Okay, so the next node here will be null. In the first case, suppose your linked list has only one node, so we'll add another node. So we'll get the node here. As this is a sequence of similar node, so this node will also going to have two blocks which have data, and as I told you, the second block of a node will contain the address of the next block. Means this node will going to have a address of the next. So if you access head.next, you will get the node 1. In the previous case, when you had only one node, your head and tail are similar, like at the same node. Now you are going to shift the tail to this node. Okay, so I will just write t here, and if you add one more node, the same thing is going to happen. You will add the node here, and it has the data, so you will just going to shift this address to this one and try to remove the value here, and this again will be going to null, and the tail will be shifted to here instead of this one. Okay, so and that will keep on increasing. Now we are going to see how we are going to do operation on a linked list. Operation means addition, deletion, add in the beginning, add in the end, so those kind of operation. So first I will going to show you addition in the last of the linked list. Okay, so as you may have remember, we have terminology head, tail, and the pointer. Here we are going to insert a value 4. So to insert the value 4, you have to traverse till the node 3, means here the value is 3. So till the third node, then you will assign the next of it to the new node. So first, as you have the head data, so we'll assign the pointer here first, then we'll shift the pointer to here, so by calling next. Then again, what you have to do, you will go to shift the pointer here. Now you will find that this node dot next is null. So you get that, okay, this is the last node as the next value is null. So what we will do, we will create a new node with value 4. We will assign this value to null, and what we will do, we will try to set the address of this node to the new node. So this is the inserting a node at the end of the linked list. Inserting the node in the head of the linked list, means in the first 0th position. Okay, now your pointer is head here, and you just created a new node. So the new node now will be data will be 4, and you know you are going to add the node in the beginning. Is this dot next will going to point to the head, and you will going to change the head to the new node. So you saw how how efficient it is and how easy it is adding a node. So the time complexity, if you remember what it is, it's big O of 1. So it's constant time complexity for adding in head. So we saw how we're going to add linked list in the head and the tail. Now we're going to add a node on the middle of the linked list, means you can see between 2 and 3. As usual, we'll point to the head. We'll check, okay, the value is 2. Say no. So we'll go to the next. Here we'll check the value is 2. Then say yes, its value is 2. So pointer is here. So now we'll create a new node. So I'll just create a new node here for a better visual representation and give the value 4. Now you can easily tell what to do from the previous example. So this next value to 4, and we just change this value to here, and we just need to break the connection here. And the time complexity here will also going to be big O of n, because the worst case you have to go to the last. Now we'll see deleting a linked list. Suppose you want to delete value 3 here, that is delete last. Again, you have the head, so you point the pointer here. Now the catch here is you need 2 pointer for a single linked list. For the double linked list, it will be different. Okay, for the single linked list, you need 2 pointers. I'll let you know why. So you had a pointer here, you had a pointer here as well. Okay, so and you will going to shift the pointer to the next value. So 2 pointer will go at the same time. So and you check, okay, this is not the last, so this next has some value, so you just point the value to here. Now you want to delete this node. So what you have to do, as I already told you, the last value will going to have null as the next. As you already reach on the third value and you have the already pointer to in the second value, you just have to do this value to be null, and you just need to clear the value for the memory corrections. And again, the time complexity of this will be big O of n because you are traversing to the end of the linked list. Now we'll see deleting the head, and deleting the head will be going to be easy like adding the head. So you got the head. What you have to do is just point the head to here and just delete the head. So it is also time complexity will be big O of 1, that is constant time complexity, and it is pretty simple as well. Now we'll see how to delete a node in between, and we're going to delete the second node. Means here the second, we have only 3 nodes, so going to delete the second node. As I already told you, you need 2 pointer to delete any node other than head. Okay, so what we'll do, we'll go to here and just check 2 pointer. Okay, we got the 2. Now the value is 2, we have to delete that one. And one tip I can give you, that if you are doing some problem using linked list, draw it. If you will draw it, it will be pretty easy to implement that also. You will going to see that after some time. To delete the 2, what you have to do, you just need to point this value to this one. Okay, so that's how you're going to delete the node in between. And this again, the time complexity of this will be also big of n, because you have to traverse to that node to delete. So before jumping into the implementation, I want to tell you something like why single linked list is used. So you can say, okay, Subrat, like, so in the double linked list we have 2 reference to the next and to the previous. So why we are going to use a single linked list which has only 1 reference? The reason is a reference is also going to take some memory. Okay, so if it's a 64-bit system, then it's going to take 8 byte, and if it's a 32-bit system, then it's going to take 4 byte. And suppose if you have a millions of nodes in the linked list, and you don't need that much of going forward and backward in the linked list, then the single linked list is pretty useful, because the memory will going to consume will be half than the double linked list. So that's the one use I can tell you. So now we're going to see the implementation of linked list in TypeScript. You can ask me, okay, Subrat, why you are using TypeScript, not JavaScript? Okay, then as TypeScript is a superset of JavaScript, and by the use of TypeScript compiler, I can generate both the code. So I can show you here, I have both the TypeScript code and the JavaScript code as well. Okay, and what I am planning is, after finishing all the data structure, I will going to publish it in npm, so that everybody can use the data structure by just calling it. They don't have to write it again and again. So on this video, I'll just cover all those topics by using the examples I already given. I will put the GitHub link in the description, so you will go to the code and ask me in any question. Don't think it's a silly or it's a small one. Ask any topic, and if you find some bug, you can raise an issue and create a pull request. I will try to merge it, or if you have an issue, just raise it, so I will try to solve that one as well. So as I told you, a linked list will going to have some terminology, that is head and tail. So here we have head and we have tail, and this is the length. I'm just counting to check the number of the how many nodes are there. I'm gonna check it here, head and the tail, and the length will be 3 for this case. Okay, and I have made it generic so that you can use any data type. It will be relevant for TypeScript, not for JavaScript. So for TypeScript, you can put any data type you want. We are checking here if we have some data. So if we are giving some data while creating a linked list, then what we will do, we're going to create a node. So as I told you, if you are creating a single node here, so suppose the first linked list means in the constructor, and we are passing some data here the data, we are passing some data here, and suppose the value is 10. So we'll check if you have some data, then we are creating a new node. So the new node got created. The head and the tail both will be going to point to the single node. So what we are doing here, we are creating a node here, then we are pointing both the head and the tail to the similar node, and we are setting the value length as 1. And if we are not sending the data, then we are setting head and tail as null, and we are setting the length of the linked list as 0. And you can see it here. So I have created a linked list. So, and I haven't passed any constructor value. So you can pass the value here also, like I can pass 90 here. So what it will do, if you pass the value, it will create a node. If you don't pass the value, it will just create an empty linked list. Okay. And in the second method is empty, and that is checking, just returning the length is equals to 0 or not. That's straightforward. Linked list implementation will be little different what I explained you. It's just little different. So we are checking here if it's empty. So if it's empty, then we are setting both head and tail as the new node. If it's not, then as you already have the tail data here, what you're doing is we are just setting, and the tail by default it will be null. And what we will do, we'll just create the new node, okay, the new node with some data. What we will do, we'll just point the tail directly to the new node, and we'll just point this to null. So this is the benefit of having a tail on a linked list. It will be efficient because here the deletion will become big O of n, as you don't need to traverse to the end of the linked list, and we are increasing the length here so that it can be trackable. So add fast is pretty easy. So as I told you, so even the example also. So what we are doing is we just created a node here, new node. We have the pointer here, so we know what this is our head. So we are first assigning this value to a temp node. Okay, then what we are doing is we are changing the head to this one. Now the head is this, and what we are setting is head dot next is the temp node. So this is simple, and here, as I already told you, the time complexity will be big of 1, so it's constant time complexity. Then here is add at, that adding in the middle of the linked list, and the add at will get the data to insert and the index where you're going to insert. If the index is 0, we're calling add first, that will going to add the link node in the first. If the index is the last of the linked list, then we are calling add last, that is link last. If it's not, then what we are doing is we assign the value here, like we have head here, we have tail here. Okay, we are iterating from 0 to the index -1. Why? Suppose I'll do that like this, 0 1 2. So suppose I pass the index as 2. Okay, so I want to insert the node at the second index of the linked list. So it will go and check till the index -1. So why I'm doing index -1 here is suppose I want to insert a node here. Suppose you want to insert a value node here, as per the previous example, your pointer should be here, so that you can point it to the next, and all this stuff you can do. So what you have to do, you have to traverse the index 1. So that's what we are doing it here, index -1. So here what we are doing is we are created the node. So this we are creating the node here. So the current node next we are storing as a temporary variable. Then what we are doing is current node. This is a current node. Current node dot next is our new node. Okay, the current node dot next is new node. This is this line, and the new node dot next is our temp node that we already stored as a temporary variable, and so that this connection will go now. So that's what we're doing with the piece of code here. Okay, so there are 3 methods. So add from, add all, and add all from. So what I want you to do is clone the code and go through these 3 methods and see what's happening here. It's just using the previous method, like add last, add first, add middle. So you will be clear once you go through the code. And if you are finding any difficulty or any mistake in my code, please comment below so that we'll rectify it. And if you are finding some better solution, so please create a pull request so that we can merge it and we can make it better. We'll go to the another one that is peak fast. So what peak fast will do, it will only tell you what is the head of the data of the head of the linked list. Okay, so we are what we are checking here, if linked list is empty, we are throwing an error, else we are just returning the data. And peak last is also same. If we are checking and returning the data. Now the delete fast. Delete fast is also like I already explained, we just need to change the head to the next node and you can delete the value here. So what you are doing is just storing the data to return, and we are changing the head to head.next, and you are decreasing the length, and here you are just checking if it's empty, then the head and tail both should be null, so you are setting the tail to null and returning the data to the user. And the delete last, as I told you, like you need 2 pointers and all, so that we're going to see here. We have current node and the previous node. So initially current node is head and the previous node will be null. So you can put it like this also, current node will be node.next and previous node will be the head. So I feel this will be better. So what we are doing is, as this delete last, we are checking till we have current node.next. So in the last node, if you remember, the last node is grounded. That means the tail node.next is null. So what we will do, we'll try to traverse till the tail node to delete the tail node. You can ask, okay Subrat, you have tail node, you can directly delete it, but we need the previous reference to make it null, so that this node can be deleted. And there double linked list is good. We're going to see in the double linked list video. When you reach the last node, then what we are doing is we are setting the previous node. As I already told you, you have 2 nodes. This is the last node. So this node data, we will grounded this one and just grounded the data and just shift the tail to the previous node, and we are decreasing the length here and returning the data. This is delete with data. Before that, I will go to the delete at, so that is similar, so this will be easy. So we are just checking the same as we did it at, and here also we need 2 pointers. We are doing the same here, but here instead of while loop we are using for loop, because we know the index where we need to delete the node. So we are traversing till that point, and in that point what we are doing is previous node dot next is to the current node dot next. So your pointer is here. So we are jumping to the next node and we are assigning the value here, the previous node dot next, the current node dot next, and we are decreasing the length. So as I told you, we will go to delete with now. Okay, so delete with is doing the same, but instead of doing it with the index, we are doing it with the data. And delete node is also same as delete with. Okay, so that in that case we are checking the node. Now all this, I think you can check, you can go through yourself and you can check. Only 2 method remains, contains and clear. It's pretty straightforward, so I'm not explaining. So and this is a generator. So the items here is nothing related to the linked list. So this is I just created so that I can show you how to print. So in the print I'm using that generator, and I'm just putting to array and putting the value here. And all this method is the implementation for the queue that is coming in the further videos. So you can see here also we are implementing the queue interface, which is an interface that anyhow we are going to see in the next videos. So here we will see how we're going to use the linked list. As you can see, what we are doing here, I have created a linked list, then I've added 3-4 value, and then I'm just doing a printed. So when I will just run the same file, so if you remember in the constructor, if we are passing the data, it's getting added to as a head, and that's what happened here. The 90s got added as the head of the linked list. So what we will do, we'll try to add more things. So we will try to add first, and we'll do suppose 100. So this 100 should be added as the beginning of the linked list. Okay, so what I will do, I will just try to zoom it here. Then as you can see, the 100 is added to the beginning of the linked list. So so this is what the linked list implementation. So please clone the code and please use it and everything. I know it's a long video, but please do it. And if you're watching till now, thank you very much. It means a lot to me. Please hit the like button if you like the video, and if you are liking my work and you want to support me, you can support me on the Patreon. I'll give the link in the description below. And If you like the code, please start the repository so that it will be visible to others. In the next video, we're going to discuss about double linked list. There is not that many difference in the implementation, but there is small difference as you have referred to the both. Now the things will be easier with some tweak. And if you don't want to miss the video, then subscribe to the channel and don't forget to hit the bell icon. And we're going to meet in the next video. Till that, stay happy. Bye bye.